Yes, good morning, good afternoon, good evening, depending on where you are. My name is CPA Makan. Today I will be taking you through a very important topic called matrices. And before I introduce the topic on matrices, first and foremost is to introduce that my YouTube channel is very active and is purely covering on specific areas on quantitative analysis, financial reporting, and financial management. And therefore, if you want more and more knowledge about accounting and about also how to do some few questions regarding quantitative analysis, taxation, and all that, I'm the one presenting and producing this topic without any discrimination. Therefore, it can be used by CPA students, can be used by ATD students, can be used by college students, can also be used by university students. So this topic of matrix is mainly on a particular subject called either business mathematics for those who are doing cutting-edge syllabus, and if you are doing the CPA is also the same, but it advances to quantitative analysis. And if you go to university, the name changes to Management Mathematics 1 and Management Mathematics 2. So the name is just changing, but we are still dealing with what? Quantitative analysis. And therefore, have a very important opportunity to learn this particular topic called matrices. And before I move further, I would like also to say yes, if you have not subscribed to my YouTube, kindly I request that you may be able to subscribe. Search CPA Makan, Simon CPA Makan, or SIPS College. You will be able to find out many videos regarding to the CPA. Therefore, welcome and enjoy the topic on matrices. Thank you. First and foremost, when we talk about a matrices, we are referring to a mathematical tool that is mainly used to measure the elements or quantity that can be put together because they are similar. For example, you can say, if there is a class of students, they are learning different subjects. These different subjects are called elements. So because they form a subjects. So therefore, if you are discussing or analyzing a group of things that are related, we call them what? Matrix. And therefore, when we talk about a matrix here, we are referring to an arrangement. It is an arrangement of data. Right? It is an arrangement of data in rows and columns. Correct? So any data that is arranged in rows and columns is what you call what? Matrix. It's an array of this. Now on this area, if we talk about rows and columns, we might find that we have arrangement of data that has more rows and more columns. And we have also those that have the same number of columns and the same number of rows. So in this case, we are going to know which are these that refer to rows and which are these that refer to columns. For instance, we can have a data like this, arranged in this format: A, B, C, D, E, F, G, H, I. This is already a matrix, and this matrix here is in the form of rows and columns. When we talk about rows, we are referring to these lines here: A, B, C, D, E, F, H, G, H, I. So these lines that move like this are called what? Rows. And these lines that when you view this data from top downwards like this, it is called what? Columns. So therefore in matrix, for you to be a very good student, to teach also others, you must first of all understand the rows and the columns. Because failure to get this, you may not be able to work out questions comprehensively. Now, once we have known now the meaning of the word matrices here, matrix here, we can now go ahead and say, yes, we have different types of matrices. And for the sake of our computation, because I'm very interested in computation, I want just to define some few which are very important in our computation. And therefore pay attention to this. So we can have types of matrices. Types of matrices. Yes. The first one is what we call identity matrices. Identity matrix. When you talk about identity matrix, it comes from the word identity, meaning one. So therefore, this is a matrix in which elements along the main diagonals are 1. So in this case, if you see that there is elements along the main diagonal are 1, meaning we have to know where is the main diagonal, because it is only those elements that are found along the main diagonal that is making that matrix called what? Identity matrix. Therefore, the rest of the matrix the rest of the elements in that matrix will be zeros. For example, we can have a number like 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1. When you look at this, when this is a matrix, so which one is the main diagonal? This is our main diagonal. So if the elements along the main diagonals are made up of ones, then and the rest are zeros, then we say that is our identity matrix. And therefore, this identity matrix is very important in our computation. The second type of matrix is what we call transpose matrix. A transpose matrix means this is the matrix that is obtained by interchanging the rows and the columns. Interchanging rows and columns. It can also the other way around. You can also say it is a matrix obtained by interchanging the columns with the rows. And it is also correct to say it is a matrix obtained by interchanging rows with the columns. For example, we can have a matrix like the one I have up here: A, B, C, D, E, F, G, H, I, J, K, L. This is our matrix. If you want to obtain a matrix called transpose matrix, we interchange the rows and the columns, or columns and the rows. For example, look at what I'm going to do. This, let me start with rows as it is. This row here, A, B, C, D, another row is made up of E, F, G, H, another row is made up of I, J, K, L. So this row here, we interchange it to be what? A column. Therefore, it is equals to A, you interchange this, A, B, C, and D. That is an interchange. So I've interchanged this row with this column. Then which row again is remaining? We have this row also can be interchanged as E, F, G, and H. Another row that is remaining is I, J, K, L. So you say now I, J, K, L. So this is what we call what? You can see I've obtained a new matrix from the original matrix by interchanging the rows and the columns. So when I do that, automatically I get what we call transpose. It is very important when it comes to the computation that I'm just about to do. Now, sometimes also you can also say or. You see, I've used the rows here. Okay? The rows. There are 3 rows here. This is now 3 by, this is 3 by 3 matrix. 3 by 4. 3 by 4 matrix. Why? 3 rows. 1, 2, 3. Columns. 1, 2, 3, 4. So it is 3 by 4 matrix. You can also obtain by saying interchange the columns with the rows. So therefore, you can just now bring this column here, this column here to be like that. So you write A here, E, then I. This one. Interchange also this. You write here B, F, and G. Interchange also this. It will be C, G, and K. We interchange this. It will give you D, H, D, H, and want you to look at the two. Look at this and this. Are they the same? The same. So therefore, this one here, when you use the rows, it will be like this. If you use the columns, it will be like this. When you check into these particular elements, they are the same. So therefore, it depends on how you will approach. The second main element is what they call submatrix. 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 I've just selected some few which are very important in our computation. Now, when you talk about a submatrix, we are talking about expansion of a given matrix to form as many matrices as possible. In this case, we are trying to multiply a given matrix to have many and many of the same kind. For example, we can have a matrix like A, B, C, and D, like this. Right? So, can we multiply this? Can we obtain as many matrices as possible? This is how it is done. This is how it is done. This is how it is done. Now, I want to demonstrate something. So if you have, these are rulers I'm going to use for this particular element. Now, for me to obtain as many matrices as possible, I can decide to close one element like that. Correct? Then I can also close this like that. Once I close, what elements are seen there? There is only one element, which is what? D. So I will write D there. Correct? Once I'm through with it, I've closed the first row, the first column, and the first row. Now then I move. I close now the second column with the first row. So when I close like this, what is remaining is letter C. I will write here C. Correct? Then I come down here and say, yes, I've finished with the first one. I can come out the first column with the second, what? Row. So I will write there, my answer will be B here. Then I will bring this and then I close like that. My answer is A. So you can see what has happened. When you look at it carefully, you find that there is an interchange of some elements. So for example, C has been moved to the last end here. D is here. D was down here, but has been moved up here, and this A has been moved up here, down there. Another example is maybe a 1, 2, 3. This 2 by 2 matrix. Let's go to 3 by 3 matrix. 2, 3, 4, 5, 6, 7, 8, 9. So this is another matrix. Let's obtain now as many matrices as possible. And remember, I'm saying this is very important when it comes to computation. Now let's see. Now I close the first row. Where is your first row? My first row is that. Then I close the second column like this. Correct? So when I close the first row and the first column, what elements can you see there? We have 5, 6, 8, and 9. So I copy them down. 5, 6, 8, and 9. I go to the second column, retaining or maintaining the first row. So I will maintain my first row, but I close the second column, which is this. When I close it like this, I will be left with 4, 6, 7, and 9. 4, 6, 7, and 9. Then I will maintain my first row. I go to the second column like that. Which elements are you seeing? 4, 5, 7, 8. So it is 4, 4, 5, 7, 8. So I'm through with the first. I'm now through with the first row. First row. Let's go to the second row. The second row means I close it like that. Then I will introduce my first. I close the first column like that. Close the first column. What can you see there? I can see 2, 3, 8, 9. So you come to the second line and say it is 2, 3. So I've closed this one like this, then like that. So sorry, I've closed the first column, the second column, first row like this. So I can see 2, 3, 8, 9. So you write there 2, 3, 8, 9. So you go to the second column. This is the first column. Go to the second column. You can see it is 1, 3, and then 7, 8. So you write there 1, 3, 7, 8. Correct? Go to the third column like that. So what can you see there? I can see 1, 2, and 7, 8. 1, 2, 7, 8. So I'm through with the second row. I go to the third row, which is this one now. I close like that. Then I close the first column like that. What am I seeing? When I close like this, it is 2, 3, 5, 6. So it is 2, 3, 5, 6. Close the second column. So you have what? 1, 4, 3, 6. 1, 4, 3, 6. The last one, close like that. You can see 1, 2, 4, 5. 1, 2, 4, 5. So I'm now through with the second row. I go to the third row, which is this one now here. I close it like that. Then I begin from the first column, like that. What can I see? 2, 3, 5, 6. So you write there 2, 3. Oh, sorry, I've already finished. Okay. I've already finished actually. Oh, I'm repeating it. So I'm already through because I was here. Like that, like that. So let me just repeat something a little bit. Let me repeat something. First column is that. First column, first row, first column. So the elements you are seeing are 5, 6, 8, and 9. So you write those elements down. 5, 6, 5, 6, 5, 6, 8, 9. Then that is the first. You have generated the first. So I'm still on the first element, first row. Then I go to the second column like that. The elements I see there is 4, 5, 7, 6. So you say 4, 6, 7, 9. Like that. Go to the third column like that. So what are you seeing? 4, 5, 7, 8. So I'm through the first row. Go to the second row. Second row is this one. So I've closed 5. I've closed 4, 5, and 6. So I have now the first row and the second row, but I have to close the first column. I'm able to see 2, 3, 8, 9. 2, 3, 8, 9. Close the second. 1, 2, then 7, 8. 1, 2, 7, 8. 1, 2, 7, not 7, 8, but 7, 9, like that. So 1, 3, like this. So 1, 3, sorry. 1, 3, like that. Then we have 1, 7, and 1, 3, 7, 9. So you put your 9 here. Then you go to the last like that. So we have 1, 2, 7, 8. So 1, 2, 7, 8. So you are through with the first and the second rows. So we go to the last row, which is now made up of 7, 8, and 9. So you just need to come and close like that. Then you close the first column. So what can you see? 2, 3, and 5, 6. So you write there 2, 3, 5, 6. Close the second column. What do you see? 1, 3, 4, 6. 1, 3, 4, 6. Like that. Close the last column. I can see. So if you close the last column like that, you will have 1, 2, 5, 4, 5. 1, 2, 4, 5. So now that is the end, because you have already finished with the first row, second row, and the third row. What you have done is that you have produced as many matrices as possible, and that is what they call sub-matrices. This is what you call what? Sub-matrices. So when you are going to handle questions relating to matrices, this concept is very important. Very, very important. Now, apart from what we have actually learned about, we can now move ahead and discuss about the inverse. Inverse. This is introduction of matrices, and therefore it is very important. Now let's see how do we compute the inverse. Now, inverse is a very simple exercise. You just want to find the reciprocal of the matrix. And let's start with the 2 by 2 matrix. 2 by 2 matrix. This one you also learned in high school. In this case, for example, a person might give you a matrix A with these elements A, B, C, D. This one is called a 2 by 2 matrix because we have 2 rows, 1, 2, and 2 columns, 1, 2. So it's called 2 by 2 matrix. So when you are given such information, you have been asked to calculate the inverse, your work is very simple. 1, you have to follow specific procedures. So let me write down some procedures of calculating inverse. Procedures. Let me write down here. Procedures. Procedure number 1. Procedure number 1 is to obtain what we call a cofactor matrix template. Cofactor matrix template. So, cofactor matrix template. When you talk about a template, it's just like a dashboard. This dashboard has signs, and we are going to use negative and positive as the main what? Dashboard in this case. For example, if you want to determine the dashboard for 2 by 2 matrix, it will be 2 by 2 matrix. It will be plus, minus, minus, plus. So you start with the plus, then minus, plus, minus. This is for 2 by 2 matrix, like this one. So I can generate a dashboard from here. Then I can also develop for 3 by 3 matrix. It will be positive, minus, positive. First row. Second row, because you have begun with the positive, you begin with the negative. Then the other one is positive, negative, the opposite. Now, because it is 3 by 3, I repeat again here, repetition. You can see this matrix here. So, this is what you call a dashboard or a template. So, the first thing you do is assign the elements these signs here. If, for example, the first A was like that, B like that, C and D like this, can you assign the template? Can you make the template from here? Yes. The first element will be positive. The second element is negative. The first element in the first row is negative. Then the fourth element in the second row is positive. Therefore, the answer here will be A, B will be negative B, then C will be negative C, and D will be positive. If it is 3 by 3 matrix. If it is 2 by 2 matrix, sorry. If it is 3 by 3 matrix, your work is also very simple. Assuming it is A, B, C, D, E, F, G, H, I, like that. The first A, it is a positive. B is negative. C is positive. The second row, D becomes negative, E becomes positive, F becomes negative. The third element, the third row, G now, is positive, H is negative, I is positive. That is what we call cofactor matrix template. Develop a template. So the template for this will be A, negative B, C, negative D, positive E, negative F, positive G, negative H, positive I. So what is this? A cofactor matrix. So the first thing you need to do is to obtain the cofactor matrix before you come and do anything. Once you have obtained now the cofactor matrix, obtain what we call, the second one is now cofactor matrices now. This is not a template. Already we have developed a template here. So that template that we have developed is now we are generating as many matrices as possible, sub-matrices here. Then the third element is to determine, the inverse, which is what we are discussing here. Then, once you get the inverse, the fourth one now is to solve the problem. If it was about equations, now that you have formed algebraic expressions, if you have formed your algebraic expression, you can now solve your problem. So these are the elements that we are going to discuss. Now, let's go to example 1 that I've written here. Matrix A is A, B, C, D. Determine what? The inverse of that element. So the first step is to determine the cofactor matrix in this case. So therefore, this one, the first step is to develop the template here. This is positive, negative, negative, positive. So then the first step is now A, negative B, then negative C, D. That is the first one. Remember, when by doing this, you have already earned a mark. After you have done that, the second step is to develop what? A cofactor matrix. Now, cofactor matrix is very simple. The way what I've just done. In this case, we interchange the elements in the main what? Diagonal. Where is your main diagonal? My main diagonal is this, which is made up of A and B. So I interchange, meaning remove D from here, put it here. Correct? Then for C and D, we don't interchange the elements, but what we do, we only interchange the signs. For example, So let me, for example, now the next step is to interchange this. So here it give me D here. This I interchange, minus comes here, minus comes there. So is there any change? No. So it will remain the same. So now be like there, then it's negative D, but here is A. See what we have done? The second step is to calculate the inverse. Calculate the inverse. And before we do the inverse, we have to do what we call determine the determinant. What is the determinant? So determinant for A by A, B, C, 2 by 2 matrix, your work is very simple. You take the product of the main diagonal, minus product of the minor diagonal. So this is our minor diagonal. So for me to get this one, I will take now the product of main diagonal. Then I multiply by product, I subtract less product of minor diagonal. And when you talk about a minor diagonal, which one are you referring to? I'm referring to this one. So therefore, our matrix here, our determinant here will be A times D. You get what? A D minus minor diagonal C D, which is C D. So this one becomes your determinant. And therefore, for example, let me now put the correct figures now. Assume we have 1, 2, 3, 4. So get the determinant here. Our determinant here will be 1 times 4. You get what? 4 minus 3 times 2. You get what? 6. So your answer is negative 2. Correct? Then from there, once you have now the determinant here, let's now obtain the inverse. What is the inverse? So in this case, I can just say A. So when you say A power negative 1, it means it's an inverse of A. So for me to get the inverse of A, I will say I write this one as a fraction, which is 1 over negative 2 times the interchange of the main diagonal, which is 4 and 1. So 4 and 1, 4 up there, 1 down. Then interchange the signs of 3 and 2. Signs, not the element, signs. So it means positive for 2, it comes here. Positive for negative. Positive for 3, it goes there. So it gives you 2 and 3 like that. So when you have been asked to give the inverse, this is your answer. You can leave it here or you can proceed and open the brackets by taking the scalar, what is outside, multiplied by each and every element in that matrix. Each and every element in the matrix. Which means I have times 4, it is negative 4 over 2. I have times 2 is negative 2 over 2. I have times 3 is negative 3 over 2. I have times 1 is negative 1 over 2. Like that. Then you can simplify and say the first one is negative 2, negative 1, 1, negative 1.5. This one is negative 0.5. So that is your answer. But if you leave your answer here, it is still correct. Okay? So that is how you are supposed to calculate the matrix of a 2 by 2 matrix. Now, let's go to 3 by 3 matrix. How do you calculate the determinant of inverse of 3 by 3 matrix? For example, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this example 2. Calculate, find the inverse of this particular matrix. So your work is very simple. First step, generate a cofactor matrix template. So the first step is the cofactor matrix template. And I've already explained that you begin with what? Positive, negative, positive, negative, positive, negative, positive, negative, positive, like that. So therefore, this gives you, this one will be 1, this one will be negative 2, this one will be positive 3, this one will be negative 4, positive 5, negative 6, positive 7, negative 8, and positive 9. So that is your cofactor matrix. The second step is to develop now our cofactor matrices. Cofactor matrices. Steps, step by step. Now, cofactor matrices. I want you to pay attention carefully on what I'm going to do. Cofactor matrices. Now, this is how I was demonstrating earlier. We deal with the first row. We ensure that we close the first row. Then we shall be moving from one column to the other until we finish the first row. This is what we are going to do. The first row is this. The first row is closed. Correct? So because the first row is closed, we go to the first row is closed, go to the first column, close also the first column, like that. What elements are you left with? 5, negative 6, negative 8, and 9. So you copy that element down. 5, negative 6, negative 8, and 9. So that is the first matrix that you have obtained. The second matrix, you still first column, first row, second column. So you have now negative 4, negative 6, 7, and 9. The last column, we have negative 4, 5, 7, and negative 8. So I'm through with the first row. I go to the second row. You close the second row. Then close the first row column. So we shall have now negative 2, 3, negative 8, 9. Close the first column. Oh, sorry. If you close the first column, your answer is negative 2, 3, negative 8, 9. Can you see that? Close the second column like that. Your answer is 1, 3, and 7, 9. So 1, 3, 7, 9. Close the last column. 1, negative 2, 1, negative 2, 7, negative 8. That is your, that is now your matrix for the generated from the second row. Go to the third row now. You close the last row like that. Then you close this also. You have now negative 2, 3, 5, negative 6. Close the second column. So we have 1, 3, negative 4, negative 6. 1, 3, negative 4, negative 6. Then the last one, like that, you have now 1, negative 2, negative 4, 5. So you have now generated your matrices, so up to the end. So those are the matrices up to the end. Then you now introduce a bigger brackets like that. Once you have finished with these, your work is now very simple. You can see it is now 2 by 2, 2 by 2 matrix, 2 by 2 matrix. Therefore, it is taking you back here. It is taking you back here. So therefore, this is now as simple as you can see, similar to what you have done here. What did you do here? So you are saying main diagonal, product of the main diagonal minus product of the minor diagonal. For each of these, now we can now say Major diagonal, which is 4. 5 times 9, you get 49. Then negative, I'm saying minus now. Minus negative 8 times negative 6, positive 48. I'm through the first one. You go to the second matrix. Negative 4 times 9, you get negative 36. Then minus 7 times negative 6, negative 42. You can see where I'm putting here. Then the last one, negative 4 times negative 8, 32, positive 32. 7 times 5, 35. So you subtract 35. So I'm through the first row. Go to the second row. Negative 2 times 9, you get negative 18. Minus negative 8 times positive 3 gives you negative 24. Into brackets, 1 times 9 is 9 minus 21. 1 times negative 8 is negative 8 minus 14. Third column, negative 2 times negative 6, positive 12. Then say minus, this times that we get what? 15. Then this negative, 1 times negative 6 is negative 6. Say minus negative 4 times positive 3 is negative 12. Then the last one is 1 times 5 is 5. Then minus negative 4 times negative 4 is positive 8. So you say minus 8. Then you introduce your big brackets like that. Then from there, you work out what is inside there. So your final answer, 49 minus 48, 1. Negative 38, it will be now plus 46. So it will give you positive 6. 32 minus 35 is negative 3. Correct? Then negative 18 minus 24 is plus. So plus what now? 6. Positive 6. Then 9 minus 21, negative 13. Then negative 8 minus 14. So it's been negative 8 plus 14 gives you what? Positive 6. Then the last one is 12 minus 18. 12 minus 15 is negative 3. Then negative 6 minus 12 gives you negative 6 plus 12. The answer is positive 6. Then 5 minus 8 is negative 3. Like that. So this is now how to obtain your cofactor matrix. So this is where the marks are. So you pay attention to each and every sign that you have done. So this is your answer. Now, once you are now through with our cofactor matrix, sorry. Cofactor matrix. So I have now my answer. The second step is to calculate what? Determinant. So what is your determinant? So in the determinant case, it was so easy when it was about 2 by 2 matrix. But when it comes to 3 by 3 matrix, you need to be very smart here. So your work is very simple. Very simple. There's no problem here. First, for you to get the matrix here, you take the original matrix as it is. Look at the matrix as it is, the original one. Then, this original one, you pick the first elements in the first row. These elements in the first row. Then you multiply with the elements in the first row that you have just obtained by adding them. You multiply as you add. How do you go about? The first element, 1 times 1 plus 2 times 6 plus 3 times negative 3. Simple. That is how to get the determinant here. So you just go to the elements in your first row, merge with the elements that you have just obtained after cofactor matrices. So your work will be 1 times 1 plus 2 times 6. Then 3 there times negative 3. Then your answer now is 1 plus 12 minus 9. So this gives you 13 minus 9 is what? 4. So your determinant is 4. Then get the inverse. How do we get the inverse? I hope you are now understanding the step by step. So I have the determinant here. I have my cofactor matrices here. What should I do? So the inverse will be the inverse of that A will equal the inverse of this, which is 1 over 4. Then the inverse of this matrix that you have obtained here, the inverse. Inverse here, I mean, in this case, you interchange the rows and the columns, transposing. So transpose this. So you can say the first row to be the first column. So first row is 1, 6, and negative 3. The first row is 1, 6, and negative 3. The second row becomes the second column, which is 6, negative 13, and 6. Then the last column, the last row becomes the last column, which is negative 3, 6, and negative 3, like that. Now, this is your inverse. So you can still proceed by opening, but no need of opening this. So you just close there. Correct? So that is how matrices are going to be calculated and determined here. And therefore, in summary, the steps are very important. Step 1. Produce what they call the cofactor matrix template. And in this case, you have said it is like this. This is when it is what? A 3 by 3 matrix. The second step is to calculate the cofactor matrices now. Cofactor matrices, this one. Once you have done the cofactor matrix, the third step is to determine the determinant. Once you have obtained the determinant, the fourth step is to do what now? The fourth step after the determinant is to get the inverse. The inverse of this determinant and the inverse of cofactor matrix. Then the fifth one is to now solve the problem. If it is algebraic expression, algebraic equations. So if you have your algebraic equations, then you can solve them. So therefore, our next lesson will be purely computation concerning what we have learned today. I have like 7 questions relating to matrices. So from question 1 to question 7, by the end of the questions, you will be able to solve a problem concerning matrices without any problem. And therefore, I say thank you so much for giving me an opportunity to introduce matrix and conclude by giving the procedures on how to solve the problems using what? Matrix. And therefore, I urge you, if you have not subscribed to my YouTube, just go there and search CPA Macan. It will just pop out, subscribe, and make sure that your bell is alert so that you are able to get the videos as they come. Thank you and have a blessed time.